Good morning, students.
Good morning, sir.
We thank you, God, for bringing us together once again. My name is Stevoo, aka Papa Stevoo. I'm here today to handle you elective mathematics for Form 3 students. In elective maths, we almost finished with all the topics, so it's left with revision for us to do. So today we are going to start one of the important topics that we need to do. We are going to look at vectors as our topic to discuss. And in vectors, together with mechanics, play a major role in the WASI questions. Vectors and mechanics takes about 20% of the questions that you have to answer. And if you don't do vectors and mechanics, you are not sure if you are A. That is why we want to look at vectors and mechanics. So that is our topic for today. Now, what is our objective for this lesson? In this lesson, by the end of it, you should be able to define a vector. Then you try to represent and write a notation for a vector. Then you also try to find the magnitude of a vector. Then you express vectors in different forms. And last but not least, we write the negative of a given vector. That is what we are going to do. So now, let's start to look at what a vector is. To define a vector, there are physical quantities that we can measure. Good. Now, to define a vector, you have to look at physical quantities, or sometimes we call them measurable quantities. They are quantities or things that we can measure. What are the things that we can measure? We can measure distance, we can measure time, we can measure temperature. These are called measurable quantities or physical quantities. Of these quantities, there are some of them that you need just one number to define it, one number to measure. For example, if you think of temperature, you need a thermometer and then use it to measure the temperature of the person. That will give you the magnitude or the size of that thing. So to measure temperature, you need only the size, which we call magnitude. To measure distance, you only take your ruler and you measure. That will measure it. These are called scalar quantities or simply scalars. So example of scalars, we have distance, we have temperature, we have time, we have speed, and so on. They are called scalar quantities. There are others. Only one number cannot describe them. You need two of them. Let's say, for example, you are standing somewhere and you want to locate your friend. And the friend tells you that I am 20 meters from where you are standing. So come. Where are you going to pass to get the person? Are you going to go right, left, or backwards or forward? The first has to also include what? The direction. So those quantities that will need the magnitude and also the direction to measure them, they are called vector quantities. So in effect, we say that a vector is any physical quantity that is measured or specified by both magnitude and what? Direction. What are some of the examples of vectors? Let's get examples of vector quantities. So, examples of vector quantities, we have displacement, we have velocity, we have acceleration, we have force, momentum, and so on. All these quantities, they require magnitude and direction to measure them. Thank you. Now, you know what a vector is. How do we represent a vector? A vector can be represented by a directed line. So you just draw a line and you give an arrow to indicate a direction. So we are saying that the length of the line represents the magnitude of the vector, and then the arrow will indicate the direction of that. Let's take an example. The displacement from the point A to the point B is represented as follows. So you have a straight line starting from A to B. Then you're given what? An arrow indicating that there is a vector AB starting from A and to B. And the length of this line represents what? The magnitude of the vector. And the arrow will indicate the direction of the vector. This is denoted by A. You start from A and ends at B. So you write AB and put an arrow on top to indicate the direction of the vector. Or if you don't need the starting and the ending of the vector, you can represent the vector by a lowercase letter like this one. There is no starting, there is no ending. You just use a lowercase letter to represent. In books or in prints, we bold the lowercase letter, but when we are writing, we just underline to indicate the vector. This is how a vector is represented. Now, vectors can also be written in different forms, and we have three forms to represent a vector. The first one is magnitude-bearing form. Second is component or column form, and last one is Cartesian coordinate form. Cartesian coordinate form. So we are going to take them one after the other and see how to represent them. Let's start with magnitude-bearing vector. Magnitude-bearing vector. You look at the diagram. There is a vector AB. Then there is a magnitude of 10 kilometers. And then there's an angle. This angle is the direction, written in what? Bearing form. So to write this vector AB, you write the magnitude 10 kilometers and also add the direction, which is what? 60 degrees. But because it is bearing, it is written in 3 digits. That is why we have 060 degrees. So this vector AB shows magnitude and then direction. So it is written in magnitude bearing form. Let's move on to the next form. That is component or column form. Over here too, we have our vector AB in the what? XY plane. So this vector AB has 3 as its component on the x-axis. Then the vector has 2 as its component on the y-axis. So you write this vector to indicate the x component and also the y component. So vector AB is equal to 3, 2. This is in component form, or you can also say it's column because it is in line. It's also column. So either component form or column form. That is for component. Then the last one, which we call Cartesian coordinate form. Some books will say Cartesian form, others will say coordinate form. They are all the same, but you say Cartesian coordinate form. Over here, we are also in the XY plane. But in XY plane, a unit in the direction of x is called I. So if a unit is I, 2 units will give you what? 2I. And then 3 units will give you 3I. In the y direction, a unit is called J. So you have what? 2J for our 2 units. So to write this vector, you write the x component first. So this vector has what? 3I plus what? 2J. So in component Cartesian form, always you have I and J. I and J form. These are the forms of vectors. Good. Let's continue. Let's look at magnitude of a vector. If the vector is given to you in magnitude bearing form, the magnitude is shown already. But in the other forms, you don't know the magnitude. So how do you find that magnitude? Good. So if you are given vector AB in magnitude form, vector AB as xy, then if you want to find its magnitude, it is indicated by vector AB. You bring the absolute bars to indicate what? The magnitude or the distance. And it's given by the square root of the sum of the squares of the components. So you square the x component, you square the y component, and you add them, you take square root of that. This will give you the magnitude of a vector. Good. So let's take examples of finding magnitude of a vector. Example 1. Find the magnitude of the vector PQ, which is equal to 3, -4. 3, -4. So I hope you have started working it. Try and find the magnitude of this vector. Let me give you some few seconds to do this before you look at the solution. Find the magnitude of the vector PQ, which is 3, -4. Okay, so let's see how you are doing it. Let's get the solution. Yeah, so magnitude of PQ is given by the square of x component plus the square of y component, all square root. And your calculator will give you 5, and then you add the units to it, because it is what? A magnitude or a distance. So that is our first example. Let's take example 2. Determine the magnitude of the vector A, which is equal to 6i plus 8j. So, as usual, you find the square root of the x square and what? The y square. I hope you are also doing it. What answer are you going to get? Let's see the solution. Magnitude of A is given by 6 square, which is the x component, plus 8 square, which is the y component. And that will give us 10. That is good. Now, you can change from one form to the other. When you are given a vector in magnitude-bearing form, you can change the component. You can also do the other way around. So you want to start with expressing vectors in component form. So the vector is given to you in magnitude-bearing form. How do you express it in component form? So let's take this. Vector A is equal to magnitude k and then the direction theta degrees. If you have this, then in component form, our vector AB is going to be the magnitude multiplied by sine of the angle, and then the y component to be the magnitude also multiplied by cos of the angle. That will give it to you in component form. Let's take an example of that. Example 1. Express vector QR, which is in magnitude bearing form, 20 kilometers, 60 degrees in component form. Let me also ask you to also try this one. How are you going to do it? You take the magnitude times sine of the angle for x component, then magnitude times cos of the angle. That will give you the y component. I hope you have done it. Let's look at the solution. So our vector QR is equal to 20 sine 60 and 20 cos 60. The calculator will give you 10 root 3 and then 10. That is good. Let's take the second example. Example 2. We should write the vector P, which is in magnitude bearing form, in Cartesian coordinate form. Good. So let's take the solution of that. Our P is equal to 10 sine 300, 10 cos 300. Calculator will give you 5, -5 root 3. This is in component form, but the question wants it in Cartesian form. So we write it as what? 5i minus 5 root 3j. So that is how we change from magnitude bearing to component. Good. Let's also look at how to change from component to magnitude bearing. Good. So expressing vectors in magnitude bearing form. First, you find the magnitude of the vector and also find the direction of the vector. Let's take example to explain that. Example 1. Express the vector AB, which is 4, 3, in magnitude bearing form. Good. So you first find the magnitude and the next the direction. I hope you have started finding the magnitude already. Let's look at the solution. So first part, you find the magnitude of the vector. That is square root of 4 square plus 3 square. That will give us what? 5 units. Then it's left with the direction. So you draw the plane, xy plane. Then the component of x is 4, positive. So in the positive direction, you write 4. And then the y is positive 3. You also write 3. Form a right angle triangle with that. Then you calculate the angle over here. So from our work in trigonometry, this is opposite and adjacent. So we are going to use tan. So tan of angle theta is equal to 3/4. You solve for theta and you get 37 degrees to the nearest degree. Then this angle here is not the direction, because the direction is bearing. It's measured from the north. So our angle or the bearing is from this side to here. But you know the total angle here is 90. So we have to subtract what we have here from 90 to get 53. So our vector AB is now 5 units, 053 degrees, which is in magnitude bearing form. Let's take second example. Find the magnitude and direction of the vector M, which is equal to 8i minus 15j. Yes, let me give you time to try this one also. Yes, you find the magnitude of this vector and you also try to find the direction, and you have that. Okay, I hope you are doing it. Yes, let's see how it goes. Yeah, you first find the magnitude of vector M, which is 8 square plus negative 15 square. That gives you 17 units. You also draw the Cartesian plane, but here you see that the x component is positive, so you are in the positive side of the x, but the y is negative, so y is negative down here, so your vector is going to be in this quadrant. So you form your right angle triangle in this quadrant. The negative only indicates where the vector is going to form, so don't include negative over here. Then you also find your theta. So opposite over adjacent is also tan. You solve this, you get theta to be 61.9 degrees. That is not our direction. Direction is measured from the north up to the vector. So this place is 90, then you add the vector and the theta to it. So our direction is 90 plus 61.9, and that will give you 151.9. So therefore our vector M is now 17 units, 151.9 degrees. That is how we change to magnitude bearing. Good. Let's move on and look at some other things. Now, when you are given a vector, you can be asked to find its negative. What is negative of a vector? A vector and its negative have the same magnitude but opposite in direction. So they will have the same magnitude but direction will be opposite. So if you are given a vector AB in component form and you want to find its negative, that is negative of vector AB, because the direction is changed, it's going to give you what? BA. And then you have to negate the components of that vector. So just negate them and then you will finish. So let's take examples on this. Example 1. If vector PQ is negative 2, 5, find vector QP. So here you see that the main vector is PQ and you want to find what? QP. So direction has been changed. So it becomes what? Negative. So what is our solution? Let's look at the solution here. Our vector QP is the same as a negative of what? PQ. So we negate the components of that vector and our answer is what? 2, negative 5. 2, negative 5. Then try this example 2 for us to see. Find vector CD if DC is negative 3i plus 2j. Find the negative of this vector. Well, so that is what we are to do today. We are going to do more on vectors, but today's lesson we want to end it here. I'll give you some assignment to try. Our next lesson, you look at more concepts in vectors. Thank you very much. So this is your assignment.